distribute the charges. That was resistor, no? Let me bring capacitor itself. So how the capacitor will behave in this case. Hmm. 5 coulomb. So this should be how much? 5 to 7, 3.5 coulomb here. Then Q1 plus 5, this will be 5 minus 2, 3. So 1.5 coulomb. So here minus 1.5 coulomb, and this will be 3.5 coulomb. So this will be the charge. So this what happened. Next, after this, I'm going to close the switch. After closing the switch, what will be the charge on all surfaces? Which charge what happened? The capacitor C1 will likes to share with capacitor C2 is what we are trying to analyze. C1 is how much? 2 farad, C2 4 farad. Which charges what happen will be shared by the plate A, B, X, Y. The plate A and X, what charge what charge will be shared by plate A with plate X? Together 5 coulomb or 3.5 coulomb or 1.5 coulomb. Only 1.5 coulomb will be shared. So this will remain as it is. This will be so called, this is Q1, Q2. So here minus Q1 plus Q2 minus Q2. So what should be the conservation of charge? Plate A index 1.5 is equal to for plate C index. So this should be 1.5 equal to Q1 plus Q2. Write loop equation. From writing loop equation, or directly you can write it Q1 by C1 equal to Q2 by C2. Solve it, you get the Q1, Q2. What about heat generated? Yes, there'll be heat generated again. You calculate energy. What to do with 3.5? Don't just bring into the consideration. That energy is permanently lying in the external to the capacitor, which is of no use. So either to the resistor or to another capacitor. So this energy will be lost permanently. Energy external to capacitors, we can't get it back. That's what here we are concluding here. So therefore, this way of giving charges is not correct itself. It's not economical, not advisable. Okay, now you can say only this charge will be shared by only 1.5 coulomb. So what is the basic idea here? 1.5 coulomb charge, 1.5 coulomb charge is shared by 1.5 coulomb charge only is shared by capacitor C1 with capacitor C2. A nice conceptual question. Then numerical, no? They may ask you like this: if their plates are given unequal charges, then unequal charges, then so and connected to another uncharged capacitor, then the capacitor C1, what charge it will share with that one? Only the charge between the plates will be shared with another capacitor. The charge lying to external to the plates, what the capacitor will not share. This is again good statement. Can be stressed in exams. You have to be very careful. Practically, it will not get disturbed practically. because I'll do one thing. See, just what happen? I'll calculate the energy in the circuit. I can measure it also, and I know here also it will be generated. Here I'll have to also stress on that. UI plus work done by cell, UF plus heat generated. What is UI? You should take only the charge, no, 1.5 plus 0 is equal to final charge Q1 square by 2C1, Q2 square by 2C2 plus heat generated. So I'll calculate all the things. Finally, what happen? I see that this charge will be there as it is. This charge will not get disturbed. So what will be the comment from him? I will not move. I am permanently settled here. So what is the only thing is by connecting, sir, I'll connect this to cell. Then also when the cell cannot disturb this 3.5. So either you take this capacitor, you connect to the resistor, you connect to the another capacitor, you connect to the cell. This will not get disturbed. Okay, I think you have chemistry class. Any particular specific question, or you just put in WhatsApp? I will respond it.